So we're going to look at two different types of chemical bonds. We're going to look at ionic bonds, which are the attractive forces between cations, which are positively charged ions, and anions, which are negatively charged ions. And then we're also going to look at covalent bonds, which occur when two nonmetal atoms share electrons. Now, regardless of the type of chemical bonds, all chemical bonds are governed by what's known as electrostatic force. And sorry about that. My sound keeps going off. So electrostatic force depends on two things. What is represented by as Q and D. So what Q stands for is charge. So an electrostatic force depends on the magnitude of the two charges that we're looking at. So in an ionic bond, this would be the charge of the cation and the charge of the anion. In a covalent bond, this would be the charge of the electrons and the charge of the nucleus that those electrons feel. And D, where's D? Right there. There's D, is the distance between the two charged particles that are being attracted to one another. So electrostatic force is directly proportional to charge. The greater the charge, the larger the electrostatic force, the stronger the bond, and then the smaller the distance between them. In other words, the closer those particles are to one another, the stronger the electrostatic force is. So electrostatic force actually only works over a very small distance. After the distance gets too large, the two particles can't feel the charges of one another, and so the electrostatic force is zero. All right, we're going to take a look at a graphic here. And this is an energy diagram. If we look at this graphic, the vertical axis is energy, and this horizontal line here is zero energy. And what this graphic is trying to show us is the relationship between energy or stability and distance. This is right here. If you look up there, you see those two circles represent atoms, and in the middle of the circle is the nucleus, which has a positive charge, and that's what is attracting electrons, not only to stay on it in an atom, but when it forms a bond as a molecule, those nuclei are attracting the bonding electrons. So we see here, if those two circles are too close to one another, if they're really close, then it's high energy because the nuclei are repelling one another. Remember that like charges repel. So as these two atoms get further and further apart, they become more energetically stable. And the distance at which the positively charged nucleus is being attracted to the negatively charged electrons and the repulsion between the two nuclei is minimized, that's going to be the bond length. That's going to be the most stable distance between these two atoms. That's what we call the bond length. I already said that, right? Okay, now once we start removing the atoms or breaking the bond, we have to put energy into it, and then once the atoms are far enough apart from one another, there's no attractive force and no interaction, and that's when we're at zero energy. So hopefully this graph will help you see that there is a very strong relationship between distance and energy, and anytime we're talking about electrostatic force, the distance between those two charged particles really matters. So to sum things up, we are going to be looking at, sorry, this is taking a minute to get to, there we go, covalent and ionic bonds. Covalent bonds Sorry about that, my sound keeps going out. So anyway, covalent, sharing of electrons between two nonmetal atoms, and ionic bonding is the attraction between positive and negatively charged ions.